Here we have a geometric problem, and it says circle P is inscribed in isosceles trapezoid QRST as shown below. So we have circle P, and it is inscribed, which means it is inside, and it is touching all four sides of the isosceles trapezoid QRST. So now it says points L, M, N, and O are points of tangency. So this means it hits, so for example, L is a point on QR and a point on circle P, and QR hits circle P at one point. The point is L. Same with all the other points. These are called points of tangency. The length of QR we have up here, it says 12 centimeters. The length of TS is 24 centimeters, and they want the length in centimeters of RS. So first what we're going to do is we're going to prove that QL is congruent to QO, RL is congruent to RM, NS is congruent to MS, and OT is congruent to NT. So first what we're going to do is we're going to make a line, straight line, making a radius, really, connecting O, the point O, to the center of the circle P. We're going to make another one, connecting P to L, and then we're going to split this big quadrilateral into two triangles, and we're going to do the same on the other side. So now we have four triangles. So first, what does it mean to be tangent to a circle? That means that we're going to have a right angle, the radius, when it meets the point of tangency, and the line hits the point of tangency and it hits the circle, it forms a right angle. So they're perpendicular. So same with this angle right here, angle PLQ. Of course, this is also a right angle, and this is also a right angle. So that's what tangent means. Now we can probably find out if these are congruent or not, and from there we can find out if LR is congruent to MR or not. And the same with OQ and LQ. So first we have a right angle right here in triangle QOP, and the same with QLP. So we're trying to prove that triangle QOP is congruent to triangle QLP. So we have an angle right here, right angle. They have an angle in common. They also have this side is congruent to this side, since all radii are congruent to each other, and OP and LP are radii. They also have QP congruent to itself. This is by reflexive property. Now we have a hypotenuse, a right angle, and a leg. That means that we know that QO must be congruent to QL based on the hypotenuse leg congruency theorem. So that means that we have QO congruent to QL. So let's just write that down. QO congruent to QL. Now let's do the same with the other two triangles. So we have PM and PL, right? These all radii are congruent. And we have a right angle right over here for both triangles, as well as, again, a triangle right over here. And as a common side right over here, and we don't know for sure if PR is congruent to PQ or not, so we're not going to label 2. And based on the hypotenuse leg theorem postulate, that means that LR is congruent to RM. So LR is congruent to RM. Now we're going to do the same, really, for the other. Oh, oops. We're going to do the same for the other 4 triangles that we're about to create. Alright, so now we're going to try to prove that triangle OPT is congruent to triangle NPT. So, first we know, again, that since the radius, and the tangent line intersect, they form a right angle. Same with this one here, this one over here, and this one over here. From here we can prove that these 2 triangles are congruent. So what we have here is we have a common side over here, TP, and we have again a radius over here, NP, and since we have a hypotenuse and a leg as well as a right angle for both triangles that are congruent, TN must be congruent to TO. So let's write that down. TN is congruent to TO. Similarly, again, we have triangle PNS, and we want to prove that that's congruent to triangle PMS. They have another hypotenuse in common, and they have, again, the radius, leg, and they have a right angle, which means that NS is congruent to MS. Now that we know all these sides are congruent, QO congruent to QL, LR congruent to RM, TN congruent to TO, and NS congruent to MS, we can now use, and we're going to prove, the tangential trapezoid property or theorem. First, we're going to label QL, and we know that QL and QO are congruent. We're going to label that as A. So this is A, right, because they're congruent. And then we know that LR congruent to RM, so we're going to label that as B. It's B. And we know that TN is congruent to TO, so we'll label this as C and C. And finally, NS and MS are congruent, so we'll label this as D and D. From here, we'll do QR. Let me change the color, actually. So we have QR. This equals, and it says up here, QL is, and QL plus RL is going to be equal to QR. These 2 sides make up this whole big side, so QL plus RL. And this is just A plus B, as we labeled up there. So A plus B, and we already know this is equal to 12. RS is equal to, and we see here, RM plus SM, and this is equal to B plus D. And this, we do not know what it is. We'll just call it, we'll just put question mark here. And let me scroll down. We got TS, which is equal to SN plus TN which is equal to C plus C. Wait, let me see. We got Sn, right? Sn plus Tn, which is C plus D. And we know this is 24. And finally, we have TQ, which is equal to TO plus QO. And this is equal to C plus A. So, and C plus A, we don't know what it is, but what we do know about C plus A, which is TQ, is that since it tells us that it's an isosceles trapezoid, that means that the two legs, QT and RS, are congruent. So we know that from the start already because it tells us that this is an isosceles trapezoid. So QT is congruent to RS. So since we have that, what we can do now is we can add this base plus this base and this leg and this leg. So here, this is what the tangential trapezoid property is. And when you see, look, RS plus TQ is the same as what we got here, B plus D. RS is just B plus D. And this equals C plus A. Or plus, sorry. We're adding them. So C plus C plus A. We'll put these in parentheses just to show that I'm grouping these. And we also have, we're going to do QR plus TS, which is A plus B plus C plus D. And notice here that we got A plus B in this one, A plus B plus C plus D. Here we have A plus B plus C plus D. So that means that when we order these around, we get that QR plus TS equals RS plus TQ. And here we don't know what RS or TQ is, but we do know that they're congruent. We know that QR is going to be 12, TS is 24, and we know that RS, let's label this X, and TQ is the same, so X plus X, we'll just do 2X there. 12 plus 24, we get 36, which equals 2X. When we divide by 2 on both sides, we get X is equal to 18. X being either RS or TQ, and in this case they want RS, so it's going to be 18 centimeters. And this just shows, and this proves the tangential trapezoid property, which shows that when you add the two bases, it's going to be equal to the sum of the two legs.